Hello to another video. We're going to be talking about the chi-square. Chi-square is based on categorical type of data, and we're going to illustrate this by using examples like tossing a die. And we're going to also realize that most of the tests with chi-square is basically whether two uh, variables are independent or independent of each other. So we're going to go ahead and take this example to illustrate this, and we're going to be using also Minitab as well. So let's assume that we have a die, and we wanted to throw the die, and we observed the number of the dies here is going to be, let's say, go ahead and do this 1, 2, 3, 4, 5, and 6. So this is the observed data. This is the observed data. Okay, the observed data. So this is too big, so let's go ahead and make it a little bit smaller, and also make sure that it's spelled correctly. And so we did actually observe data. Okay. So what are we going to go ahead and do here? In the first time, I'm using the same videos from the gentleman I showed you earlier, 24. And I could change it if you want, 24 to 38, 30 for number 4, and also 46 and 45. Okay, and I'm going to go ahead and get you to see the, as a credit to that gentleman, this is basically the videos is where I got the data from, and the main ideas behind the videos. Here we go. So just in case. And so what is the probability of getting each of those numbers, 1, 2, 3, 4, 5, 6 in a die? Obviously it is 1 over 6. So we're going to go ahead and say 1 over 6. So we're going to go ahead and say the expected values for each of those is going to be, first of all, we have to count those. We have to count how many of these, and we're going to sum them. Okay, that's why I like Excel. It's much easier to deal with. And here we go. And it's 204. So the observed value is 22 for 1, but the expected value, because it's always going to have 1 over 6, which is the 204 divided by, or multiply in this case, by 1 divided by 6. It's going to give me 34. Believe me, it's going to be the same thing for everyone because, as you notice, the 2 is going to be the same thing, 204 multiplied by 6, 1 over 6, and so forth. So this is basically the observed value, and this is basically the expected value. So what are we going to do to start with the null hypothesis? The null hypothesis, we wanted to say the null hypothesis, we're going to say this is, I'm going to go ahead and say the die that they use is fair. So there's nothing wrong with it. But the alternative hypothesis, the die is not fair. So we're going to go ahead, it's just like this is the acceptance of the null hypothesis. This is rejecting the null hypothesis, leading to the die is not fair. So how we do actually run this, first of all, this is the null hypothesis. We're going to get the second item that we're going to go about is to go ahead and determine alpha. Okay, I'm going to go ahead and do alpha at 0.05. Okay, and also we're going to get that critical region for the chi-square. And that's really very interesting because we're going to determine the degree of the freedom. We have 6 outcomes. 1, 2, 3, 4, 5. So the degree of freedom is going to be the number of the outcome minus 1, which is going to be 5. Okay, so that's what we're going to be used in the Minitab. So I'm going to go to the Minitab, and I'm going to go to the graph. I'm going to probability distribution, and I'm going to go ahead and choose now chi-square. So I'm going to go ahead and scroll all the way up to chi-square. Here we go. And the degree of the freedom, we decided to be 5. And we're going to go to the shaded area at 0.5 type of probability. The chi-square, we're going to use the right tail. It could be very complicated, but for this class, we're going to stick with one approach to it, the right tail. And we're going to go ahead and say, okay. And notice that the critical value for the chi-square, 11.07. 11.07. So I'm going to go back to my Excel in that case and state that the critical value is 11.07. So if I calculated my chi-square and it became resulted into a value greater than 11.07, then we're going to reject the null hypothesis that the die is fair and accept the fact that the die is not fair. So let's go ahead and get us the formula. The formula for the chi-square is going to be stated as this: the sum of all, which is the sigma, the sum of the observed values minus the expected value, of course, square. Okay, let's go ahead and dig this one here. It's a little bit different here. This is square. Okay, squared, and that is, sorry, square divided by the expected value. So let me take this here. The observed value minus the expected value, both of them are the raised to the square, but that's going to be the sum of all of them. So let's go ahead and put those into bracket. So let's go ahead and do that as we do it. Okay, I'm going to go ahead and put a single quote to let Excel leave me alone by treating it as a comment instead of as a formula, and actually try to do the formula. So for the first one, we're going to say 22, that's the observed value, minus 34, which is the expected value, raised to the second power, and the whole result divided by the expected value 34. So this is basically for the first one, and I could do that, continue to put that into a parentheses here, and I could continue the sum plus again the 24 minus 34 raised to the second power, and that is going to be divided by 34 as well. And this should be the second, for the second observed value. Then I could go ahead and continue to do that. 38 minus 34 raised to the second power divided by 34. And let's go ahead and also go ahead and do this. Make sure that the parentheses are correct. And again, we could go ahead and do that. 30 minus 34, and that's raised to the second power. The caret sign is the power divided by 34, and the whole thing is going to be plus. Okay, and again, we're going to go ahead and date 46 minus 34 raised to the second power, and the whole thing is going to be, divided by, no, I need to do this here, divided by 34, and another one, which is the last one, 44 minus 34 raised to the second power, and that is going to be divided by 34, and here we go. I don't know, it's going to be 15.2, 15.2. See, the sum of every this minus this divided by this minus the square divided by the 34 is the observed value, which is 22, minus the expected value raised to the second power divided by 8. So now we get this value here. As you notice that this value is 15.2929, and if we go back to this value here, is 59 greater than if this is basically greater than the result of all this, sorry here, is this greater than 11.07? It's true. That means we reject the null hypothesis. We reject the null hypothesis, and indeed, the die is unfair. Somebody's cheating us. Maybe the casino or the person who's really running the die is not an honest person. I hope you enjoyed this, and I will continue to do more videos if you wish to do so, but not for now. Those is going to really cover what we need to know. Thank you so much, and I hope you all watch the